If this is your first time seeing one of my videos, welcome to the Subaru Sambar Diaz Classic TDI swap. First, a little background about me. I'm a semi-retired old guy who has always loved cars and motorbikes. A few years ago, I retired from bikes and bought 4 K-cars from Japan. I've had a wonderful time refurbishing them and even offered them to the public for rent in the past. I've recently reduced that number of cars to just 2, one of which is a Sambar van. I absolutely love it, except for the lack of power. I can barely keep up with traffic, so I'm trying to upgrade the engine. I'm not a mechanic by formal training, nor am I a fabricator, so it is possible that I cannot make this work. But if it does, I will have about 100 horsepower, which is about triple the original level. And more importantly, I will have 145 foot-pounds of torque. That's more than 4 times the current torque level. Additionally, the 1.9-liter Volkswagen diesel has a reputation for longevity, and I expect to see around 40 miles per gallon. In the prior update, we ended with the engine running, but with an oil leak in my dopey-looking oil distribution manifold. I've made some repairs, but it needs to be tested. The weather has been uncooperative lately, and I'm not willing to run this engine inside my garage. My wife has been exceptionally patient with my tinkering, noise, and mess. But if the house reeks of exhaust fumes, that would be a bridge too far, I think. Best not to run it in the garage, even for a minute. Please have fun mocking the poor welds that I made. They deserve it. Aside from my lack of skill with a welder, the machine I have provides only 4 power settings. The tubing I chose to use was thin, and even on the lowest setting, I could not make a continuous bead without melting through the parts. I had to stop and let the part cool after every 5 seconds of welding. I'm already most of the way through my budget on this project, so I couldn't afford to buy a better welder. If I do another engine swap after this one, I will budget for a new welder before I start. On the subject of potential future K-car engine swaps, I do have another K-car and an idea that is way beyond my current skill set. One thing is certain, if I can't make this swap turn out right, I'll never mention my idea for my Honda Beat. After this test run, I had a few things to take care of. Of course, the unexpected oil leak, but also the Transaxle had to come back off. When I assembled for this test, I did not use permanent Loctite on the flywheel or the clutch assembly bolts prior to this test run because I needed to first verify there was no rubbing, no rattling, and no vibration from the Transaxle. Now that I've confirmed that this works, there's no vibration, rattle, or scraping, I need to take it all apart again so I can lock it down. One of the things that I was worried about was the possibility of getting the flywheel either off-center or uneven vertically. This possibility existed because I had to extend the flywheel away from the crank the same distance I moved the transmission from the engine by using this adapter. The total thickness of the adapter I made is 3/8 of an inch, which of course means the transmission input shaft also moves 3/8 of an inch away from the engine. Without extending the flywheel out the same distance, there would be 3 main problems. Number 1, as already mentioned, the transmission input shaft would have 3/8 of an inch fewer splines with which to grip the clutch disc. Now, given the relatively low power of this engine, it might have been okay with less material in contact. However, number 2 would not have been okay. Number 2 is, without a spacer on the flywheel, the clutch fork and throwout bearing, which disengaged the clutch, would have been 3/8 of an inch further away from the clutch pressure plate. It is possible that I would not have been able to disengage the clutch when stopping or shifting gears. Number 3 is the electric starter motor would also be 3/8 of an inch further away from the flywheel, which is ringed with teeth needed to spin the engine to start it. Losing 3/8 of an inch mating surface between the electric starter motor and the flywheel starter teeth means they only had a tiny surface area where they actually made contact. I tried to start the engine without moving the flywheel, and it did not work. The electric starter motor slipped and could not spin the engine. On the topic of moving the flywheel back, here is a montage on that process. apart again. Of course, I welded up the leak on the oil distribution manifold. The problem now is that I have welded so much on this part, it has warped. I chose 1/8 inch steel for the base plate, and I've had to grind the face flat several times after welding. At this point, the base plate is too thin for any additional grinding, so I had to weld a bead of metal along the outline of the gasket so that I had more metal to grind flat and thus ensure that the gasket would seal. At this point, I had the clutch, flywheel, and bell housing bolts, which needed thread locker, taken care of. Time to install the transmission in its new clocked position, possibly for the final time. Meaning, unless I've forgotten something or something goes wrong, I should not have to remove the transaxle again. I'm unable to use the original dust shield for the bell housing, given that the transaxle is now in a clocked position. That leaves me with 2 gaping holes through which water, road debris, rocks, gravel, all sorts of things could enter the clutch area, so I've got to cover that up. By the time this project is complete, I estimate I'm going to be adding between 140 and 180 pounds to the rear of this vehicle. It's possible it ends up being even more than that, because running the accessories like the air conditioner, that's going to be really tough in this situation. I may end up having an electrically driven AC compressor, and that means a bigger alternator and probably an additional battery. The weight of this may exceed 230 pounds. As you can imagine, I'm looking for weight savings, and I had hoped that I would be able to build the dust shields out of high-density polyethylene. But because I only had 1/2 inch thick material available, I had to use steel on the lower. The reason being, there wasn't enough clearance between the oil pan and the bell housing. So I ended up with an upper cover made of high-density polyethylene and a lower cover made of 16-gauge mild steel. Now that I'm confident the adapter plate to clock the transmission is in the right configuration, I'll add some bushings to the 2 main bolt holes from which everything hangs. I welded these onto the adapter plate, but I did not video it. Time for another test run. This time I will have all of the components of the oiling system installed, including the turbo. Because of the loss of liquid cooling for the engine oil, I put together a combination of remote oil filter and an oil-to-air heat exchanger. During this test, I'm running the oil feed line that supplies the turbo straight into a clear container. I need to verify there's proper oil flow to the turbocharger before I seal that up and forget about it. To help this make sense, take a look at how the oil flow moves now. Pressurized oil from the pump follows this line to the oil filter. After the oil traverses the filter, it follows this line to the heat exchanger. Immediately upon exit of the heat exchanger, the oil is mostly directed back to the engine, with a small amount being diverted to the turbocharger. Prior to startup, I cracked open the injector connections and spun the engine over with the starter. This is necessary to purge the air out of the fuel lines that got in there since I last took things apart. Just from spinning the engine with the electric starter, I can see that oil is being delivered to the line that feeds the turbocharger. I also want to verify that oil is reaching the head and camshaft, so this test will be run with the valve cover off. I can't tell if my oil manifold repair worked or not because the cam was slinging oil all over the place, but I am sure the turbo and the head are getting oil. I feel pretty good at this point, like I have reached a milestone. It seemed that it was time to build a cradle for moving and positioning the powertrain under the Sambar. Experience leads me to believe that the best approach to this is to build a rolling dolly that holds the powertrain in both the height and the angle I hope to make work. Because this engine is so dramatically different in dimensions and orientation, using the engine hoist that you've seen me using before would not be the best approach. So I positioned the dolly under the engine, lowered it, and slowly added blocks until the powertrain was at both the approximate height and the approximate angle I wanted. On the topic of how high the engine needs to be above the ground, I measured from the lowest point of the stock powertrain to the ground, and I found it to be about 6.5 inches. My van rolls on 13-inch wheels rather than the stock 12 inches, so keep that in mind if you're considering a similar swap. At this point, I do not have the engine level, obviously, so I keep screwing in wooden blocks until I get a cradle that holds the powertrain level. I also want the engine to be rotated approximately 15 to 25 degrees when it comes to rest in the chassis. That rotation will give slightly more ground clearance for the shift cables and their attachment points at the bottom of the transmission. I'm not worried about proper oil drainage from the cylinder head with this lean angle because the engine has oil return galleys on both sides of the head. Now I was really feeling good, like I had accomplished something big. But when I looked at the oil picture more closely, I saw a problem. While it may not be clear on video, the oil, which was headed to the turbocharger, is aerated. Thousands of tiny air bubbles I did not notice before. Aerated oil is a very poor lubricant, so this is serious. My reasoning goes like this. First, list all the possible causes, then rank them based on probability. Pick the one which would be the easiest to verify and start inspecting there. Possibility number 1, my design is bad, and that causes the oil to become aerated. Possibility 2, air was introduced into the oil by the oil pump pushing oil into the lines and the heat exchanger for the first time, mixing that oil with the air in those empty lines and the empty heat exchanger. And number 3, the oil pump itself is bad and mixing air with the oil. I chose to begin my inspection with item number 3. Please enjoy this oil pump montage while I fume about yet another delay. So there you have it. You are all caught up on the project, and I'm at a standstill waiting for a new oil pump to arrive. To that point, no video next week because I might not even have anything to show you. Thank you to the new subscribers, and thanks to the rest of you for the encouraging words. One of the things I love about these silly little cars is how they can bring us together. I'll be back in 2 weeks.